Assalamu alaikum. Today is our online lecture 14. Today's lecture is about energy and power in the circuits. As you already know that we studied before about electricity, that electricity is actually not technically running inside our wires or circuits. Electricity is just the name of transfer of energy from one particle to another, and this is how electricity travel or energy is transferred. So today we will do some numericals related to energy and power in our circuits. So let's first talk about electrical power in circuits. So electrical power, which is also represented by letter P in a circuit, is the rate at which energy is observed, absorbed or produced within a circuit. So electrical power is basically the rate of how much energy is absorbed or produced in a circuit. So as electricity is the transfer of energy and electrical power is the rate of energy absorbed or produced. A source of energy such as a voltage will produce or deliver power while the connected load observes it. So light bulbs and heaters, for example, absorb electrical power and convert it into either heat or light or both type of energy. The higher their value or rating in watts, the more electrical power they are likely to consume. So actually inside an electrical devices, because here we are talking about electrical power, the actual work is process that is going on is not the transfer of just only the energy, but conversion of energy from one form to another. And this is also one of the difference between electrical and electronic devices, because in electrical devices the form of energy is converted, maybe into heat, into thermal, into light or any other. But in electronic devices, current is controlled for performing some specific applications. So this is also electrical power, the rate of energy absorbing or producing. This means the rate of change of energy from one form to another is called electrical power. What is energy and power? So power can also be defined as the rate at which energy is transferred. Like once I give you an example of water running into a pipe. So what was the pressure? Voltage. And current is the flow. So same like here, power is defined as the rate at which energy is transferred, low power or high power. That's why we call low power devices or high power devices, because in low power the rate of energy transfer is very low and the rate of energy is very high in high power electrical devices. In an electric circuit, electrical energy is continuously converted into other forms of energy. For example, when a current flows in a conductor, electrical energy is converted into thermal energy within the conductor. The electrical field supplied by the voltage source accelerates the free electrons, increasing their kinetic energy for a short time, and this increased kinetic energy is converted into thermal energy through collisions with the ions of lattice structure of the conductor. So this is explained in this paragraph, that how current flows and how the energy is converted from electrical to thermal. So let's talk about energy. Energy we always measured in joule, and power is always measured in watts. So power is the rate at which energy is transferred, and 1 watt is equal to 1 joule per second. So let's talk about some formula. For energy we will use VIT, where E represents energy, that is in joule, while V represents the potential difference in the voltages. Potential difference in the voltages. And I represent the currents, and it's always measured in ampere, while the last one T is for time, and it will be measured in seconds. Secondly, if we want to measure the current or power, we will use the formula P is equal to VI, where P is the power and it will be measured in watts. Again, V is the potential difference in volts, and I is the current in amperes. Now if we want to calculate the power, so P will be in the watts, I will be current in the ampere, and R is the resistance in ohm. So let's start numerical 1. So the numerical states that how much energy is dissipated by a resistor if a potential difference of 9 volt is applied to it for 331 seconds and a current of 0.23 ampere flows through it. So actually what it's asking for, how much energy is dissipated. From this it's clear that we have to find the energy, and for energy this is the formula we'll be using, E is equal to VIT. So now see what's they already given. Potential difference they have given of 9 volts. Second, what they have given, seconds. 9 volts are applied in 331 seconds and a current of 0.23 ampere. So we will put the values of potential difference, that is 9.0, and current in amperes is 0.23 and seconds is 331. So the energy that is distributed by a resistor in the case where potential difference is 9 volt and applied in 331 seconds while current flow was 2.23 ampere, so the energy distributed is 690 joule. So now takes the numerical 2. What is the current flow through a bulb if it has a power of 100 watt when the potential difference applied to it is 230 volts? So first of all, when the numerical will come, we will check that what they are asking for. So in this numerical, it's clear that what is the current flowing. So this means we have to find the flow of the current, where through a bulb which has a power of 100 watts and a potential difference is 230 volts. So we will use the formula P is equal to VI, because we two things are given to us, potential difference and current. So P is equal to VI and we have to find the current, so I is equal to P over V. What was the P value? That was 100 watts. And what was the value of potential difference? That is 230. So the total current flowing through the bulb is 0.43 ampere. Now the third numerical. So what is the power dissipated by a 32 ohm resistor when a current of 1.4 ampere flows through it? Okay, here what is asking for, it asking what is the power dissipated. Okay, power dissipated formula, we will use P is equal to I square R. Why? Because resistance is given 32 ohm, and secondly what we have current flow, that is 1.4 ampere. So the power dissipated by a 32 ohm resistor and 1.4 ampere current is 63 watt. So such type of numericals can come from this topic, energy and power in circuits. So for more theory you can also consult the book. There is two or three uh, topics about electrical power in circuits. And furthermore, if you get any issue while doing numericals or in theory, you can also contact me. So this was our I think last lecture before midterm, and from onward after the midterm we will continue with this applied physics next session. So thank you for today's lecture.